let's go over it then. Okay, so when we say something is an absolute max, we mean it's the biggest of all. And the absolute max of this function is 6, the biggest it gets to. It gets to an absolute max of 6 when x is equal to 7. So when x is 7, the absolute is 6. So when we're talking about maximum and minimum values of a function, we're talking about the y value. The x value is when that absolute occurs. So just make sure you differentiate between, did they want the y or the x value when you get a question. Absolute min means what's the smallest this ever gets to be? Well, the smallest this ever is 1. We have a minimum of 1 when x is 2. Or I guess we could be writing the coordinates down as well. The word relative just means, like, in my neighborhood, relative to me, what's the biggest this function is? Well, if you're just not looking at the whole picture, and you're just looking at a part of the picture, then we see a relative max of 5 when x is 4. So we have a relative max of 5 at that point. And we have a relative minimum value actually right here. If we're just looking not at the whole big picture, but just at part of the picture, we'd say we have a relative min of 3 when x is 5. And there's another relative min, a relative min of 2 when x is 9. So when you're looking at a graph, I think stating relative max and mins is pretty easy. If you read the definition of what it means to be an absolute max or an absolute min, it sounds super complicated. Please be aware that this is just as easy as looking at this graph and saying, oh, that's the biggest point, and that's the smallest one. Okay, but here's the formal definition. If the function evaluated at c is bigger than or equal to the function at x for all x in the domain of the function, then f at c is the absolute maximum. Okay, so a math sentence here is kind of like a whole paragraph in English. It sounds super complicated. It's just saying that's the biggest. Why is it the biggest? Put it through the rubric of the definition. The value, the y value of 6 that I get when I put 7 into this function is bigger than any other y value for this whole function if I look at the entire domain. And then we just say it in the opposite direction when we want the min. We talk about extreme values of functions. When you hear the word extreme values, it means find the maximum and the minimum, and saying extreme means both. And I didn't have to say 2 words. That's all. Okay, I have a question for you. What can you say about the derivative of the function when you are at an extreme value? What can you say about the first derivative of that function when you are at an extreme value? Either a max or a min. Anybody? What's a derivative? The slope of a tangent line to a curve at any point. What's the slope of the tangent line to the curve at that max? And at that one? And at that one? And at this one? Is it? It's actually not defined. And at this one? It's actually not defined. So when you are at a max or a min, it seems like that's what's going to happen. You're going to have a derivative that is either 0 or undefined. We will call those critical numbers. Okay, so what are the extreme values for the function y equals x squared? Let's graph it. Just a quick little sketch. Has a vertex at 0, 0, and it opens up. And it has a domain of all reals and a range of all reals. Does it have an absolute max? Is there a y value that just nothing can get bigger than? No. Okay, so there is none. Why not? Because this increases without bound. What about an absolute min? Is there a smallest y value? Yeah, 0. And it happens when x is 0. Let's do the same thing for this one on this interval. So the graph of 1 minus x squared, which is a parabola that has a vertex at 0, 1, and it opens down in a basic pattern as an over 1, down 1, and keep the symmetry. And we're going to go from 0 to 1. So we're just looking actually at that part right there. And this here should be an open circle. Okay, so on this domain from closed circle 0 to open circle 1, does this have an absolute max? And if so, what is it? Biggest this gets? 1. Do we have an absolute min? What's the smallest this gets? Does it get to 0? No. Does it get close? But no matter how close you get, I could always come up with a number smaller. So this one has none because of the open circle. Easy chapter, right? Okay, there's something called Fermat's theorem that helps you find maximums and minimums at critical points. And we use the little letter C to indicate we've got a critical point. So this is the theorem. If a function has a local max or min at C, so this C, of course, refers to the x value, then either the derivative there is 0 or the derivative doesn't exist. Don't think that Fermat's theorem will readily locate extreme values simply by setting the derivative equal to 0 and solving for x. So let's just look at a couple of examples. So if f at x is equal to x cubed, then this function, we all remember what this looks like? Remember the polynomial dance we had? Okay. Then what's the derivative? F prime at x would be 3x squared. And f prime at x would equal 0 if 3x squared was equal to 0, which means x was equal to 0. Okay, and it's true. We have a slope of a tangent line to the curve right here is 0. But is 0 the absolute min or max? Well, there is no absolute min. This keeps on going down, down, down. There is no absolute max. It keeps on going up, up, up. So the absolute max doesn't exist. There is none. The absolute min does not exist. There is none. Even though we found this critical number at 0. Hey, so have you ever heard this phrase, necessary and sufficient? How do you spell necessary? I want to double every letter.